Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like inequalities, sequences and series, quadratic equations, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, trigonometry. So let us start with today's video. In this topic, we'll be seeing what are trigonometric ratios like sine theta, cos theta, tan theta, and so on. And we'll be also seeing the relation between these trigonometric ratios. Post that, we'll be seeing what would be the sign of these trigonometric ratios in each quadrant. That is, what would be the sign of these trigonometric ratios for some range of angles. For example, when the angle is between 90 degree and 180 degree, sine theta and cosec theta are positive, whereas rest of the trigonometric ratios are negative and so on. Post that, we'll be seeing the values of these trigonometric ratios for some standard angles. Like sine 30 is 1 by 2, sine 60 is root 3 by 2, and so on. We'd be also seeing the graph of some trigonometric functions like sine theta, cos theta, and tan theta. Post that, we'd be seeing some important trigonometric identities and some advanced formulas. And finally, we'd be seeing heights and distances, where we'd be covering what are angle of elevation and angle of depression, and we'd be also doing some questions based on these concepts. So let us begin with what are trigonometric ratios. Whenever we come across this topic trigonometry, the triangle that we have to deal with is a right angle triangle. A right angle triangle is a triangle where one of the angle is 90 degree. And if we consider the other angle to be theta, in that case, the side BC is called as the base, the side AB is called as the perpendicular or height, and the side AC is called as the hypotenuse. And in this right angle triangle, we can use one theorem known as Pythagoras theorem, which states that in a right angle triangle, hypotenuse square will be equal to the sum of the squares of the other two sides. That is perpendicular square plus base square. So for this triangle, we can write AC square equal to AB square plus BC square. Now, for a right angle triangle, there are 6 trigonometric ratios: sine, cos, tan, cot, sec, and cosec. And if this angle is theta, then sine of this angle is given by perpendicular upon hypotenuse. That is, for this triangle, sine theta would be AB upon AC. In a similar way, cos of this angle is given by base upon hypotenuse. So for this triangle, this would be BC upon AC. And tan theta is given by perpendicular upon base. So this would be AB upon BC. In a similar way, cot theta is base upon perpendicular. So this would be BC by AB. Sec theta is hypotenuse upon base. So this would be AC by BC. And cosec theta is hypotenuse upon perpendicular. So this would be AC upon AB. Now, if we observe carefully, sine theta is AB upon AC and cosec theta is AC upon AB. So sine theta can be written as 1 upon cosec theta, or cosec theta can be written as 1 upon sine theta. In a similar way, cos theta is BC upon AC and sec theta is AC upon BC. So cos theta can be written as 1 upon sec theta, or sec theta can be written as 1 upon cos theta. In a similar way, tan theta is AB upon BC and cot theta is BC upon AB. So tan theta can be written as 1 upon cot theta, or cot theta can be written as 1 upon tan theta. Now, if we divide sin theta and cos theta, in that case, we'd be getting AB upon AC divided by BC upon AC. And we can cancel this AC and AC and we'd be left with AB upon BC. And AB upon BC is given by tan theta. So tan theta can be written as sin theta upon cos theta. In a similar way, cot theta can be written as cos theta upon sin theta. Now, there are three very important relations which we can derive from these trigonometric ratios, which are sin square theta plus cos square theta equal to 1, cosec square theta is equal to 1 plus cot square theta, and sec square theta is equal to 1 plus tan square theta. Well, these relations, including the trigonometric ratios, are very important. So I would suggest you all to remember these relations. Now, let us see the signs of these trigonometric ratios in different quadrants. In the first quadrant, that is, when the angle is between 0 and 90 degree, in that case, all the trigonometric ratios would be positive. That is, sine, cos, tan, cot, sec, and cosec of any angle that is lying between 0 and 90 degree will have a positive value. But if the angle is lying between 90 degree and 180 degree, in that case, only the trigonometric ratio sine and cosec would give us a positive value, and rest of the trigonometric ratio will give us a negative value. For example, sine of 120 degree would be a positive value, but cos of 120 degree would be giving us a negative value, and so on. In a similar way, if the angle is lying between 180 degree and 270 degree, in that case, only tan and cot of that angle would be positive, and rest of the trigonometric ratios of that angle would be negative. For example, tan of 200 degree would be a positive value, whereas sine of 200 degree would be a negative value, and so on. In a similar way, if the angle is between 270 degree and 360 degree, in that case, only the trigonometric ratio sec and cos will give us a positive value, and the rest of the trigonometric ratio of that angle would give us a negative value. For example, sec of 300 degree would be a positive value, whereas tan of 300 degree would be a negative value, and so on. So in the first quadrant, all the trigonometric ratios would be positive. In the second quadrant, only sine and cosec would be positive. In the third quadrant, only tan and cot would be positive. And in the fourth quadrant, only sec and cos would be positive, and rest of the trigonometric ratios would be negative. Now let us see the values of trigonometric ratios of some standard angles. Some of the standard angles can be considered as 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And let us see the value of these trigonometric ratios for these standard angles. The value of sine 0 is 0. The value of sine 30 is 1 by 2. The value of sine 45 degree is 1 upon root 2. The value of sine 60 is root 3 by 2. And the value of sine 90 is 1. Now, we just have to remember the first row, that is the value of sine 0, sine 30, sine 45, sine 60, and sine 90. And based on these values, we can fill the complete table. Because if we know the value of sine of these angles, then we can find the corresponding values of cos of these angles. Simply by using the trigonometric ratio relation, sin square theta plus cos square theta equal to 1. So if sin 0 is 0, in that case cos 0 would be 1. In a similar way, if sin 30 is 1 by 2, in that case cos 30 would be root 3 by 2. In a similar way, cos 45 will also be 1 by root 2, cos 60 would be 1 by 2, and cos 90 would be 0. Now we have seen tan theta is given by sin theta upon cos theta. So tan 0 would be sin 0 upon cos 0, which would be 0. In a similar way, tan 30 would be sin 30 upon cos 30. So this would be 1 by 2 upon root 3 by 2. So this would be 1 upon root 3. In a similar way, tan 45 would be 1, tan 60 would be root 3, and tan 90 would be infinity. We have also seen the trigonometric ratios cot, sec, and cosec are the reciprocal of tan, cos, and sine respectively. So the value of this trigonometric ratio for these standard angles can be written directly, which would be these values. For example, cot 30 degree would be root 3, sec 60 degree would be 2, cosec 45 degree would be root 2, and so on. So we just have to remember the first row, based on which we can remember the complete table. Now we can also find the value of trigonometric ratios of angles more than 90 degree, simply by expressing the angle as an odd or even multiple of 90 degree, and by using the rule of sign of trigonometric ratios. If it's an odd multiple of 90 degree, in that case, the trigonometric ratio sign would be changed to cos. The trigonometric ratio tan would be changed to cot, and the trigonometric ratio sec would be changed to cosec. And vice versa. That is, cos will change to sine, cot will change to tan, and cosec will change to sec. And if it's an even multiple of 90, in that case, the trigonometric ratio will remain the same. For example, say if you want to find the value of sine 120 degree. First, we need to express this 120 degree as a multiple of 90. So this can be written as sine 1 times of 90 plus 30. Now, since this is an odd multiple of 90, so sine would be changed to cos. So this would be cos, and we'll be putting the angle here. So this would be cos 30. And by using the sign of trigonometric ratio, we know 120 degree is lying in the second quadrant, and sine of any angle that lies in the second quadrant is positive. So we'll keep it as positive. So the value of sine 120 degree would be same as cos 30, and from this table we know cos 30 is root 3 by 2. So this would be root 3 by 2. In a similar way, if we want to find the value of say tan 330 degree, so first we need to express 330 as a multiple of 90. So this can be written as tan 3 times of 90 plus 60 degree. And here again, it's an odd multiple of 90. So 10 would be changed to cot. So this would be cot, and here the angle is 60. So this would be cos 60. And 330 degree lies in the fourth quadrant. And in the fourth quadrant, only sec and cos of any angle are positive. So tan 330 would be negative. So we'd be putting a negative sign here. And from this table, we know cot 60 is 1 by root 3. So this would be minus 1 upon root 3. Well, some of you might be thinking to write tan 330 as tan of 4 times of 90 minus 30 degree. Well, we can write 330 in this way as well, and we can apply the same logic here. Here, it's an even multiple of 90, so 10 would remain as 10, and the angle here is 30, so this would be tan 30, and 330 lies in the fourth quadrant, so this would be negative sign. And from this table, we know tan 30 is 1 by root 3, so this would be minus 1 upon root 3, which is same as when 330 is written as odd times of 90 plus 60. So for such kind of cases, either we can write it as odd times of 90 plus some angle, or even times of 90 minus some angle, and both of this will give us the same value. So by using this logic, sine 90 minus theta can be written as cos theta, and cos 90 minus theta can be written as sine theta. Now, let us apply the learnings that we have seen to find the value of this expression. So we have been given as sine square 20 plus sine square 30 plus sine square 45 plus sine square 60 plus sine square 70 plus sine square 90, and we need to find the value of this expression. Well, from the table, we can directly write the value of sine 30, sine 45, sine 60, and sine 90. But we don't know the value of sine 20 and sine 70. But we know sine square theta plus cos square theta is 1, and sine of 90 minus theta can be written as cos theta. So using this, sine 20 can be written as sine 90 minus 70, which can be written as cos 70. So sine square 20 plus sine square 70 will be giving us cos square 70 plus sine square 70. And this is of the form of sine square theta plus cos square theta, so this can be written as 1. So sine square 20 plus sine square 70 would be giving us 1, and we know sine 30 is given by 1 by 2, sine 45 is given by 1 by root 2, sine 60 is given by root 3 by 2, and sine 90 is given by 1. So if we put all these values in this expression, in that case, we'd be getting sine square 20 plus sine square 70 as 1, plus sine square 30 would be 1 by 2 whole square, plus sine square 45 would be 1 by root 2 whole square, sine square 60 would be root 3 by 2 whole square, and sine square 90 would be 1 square. And if we simplify this, this would be 7 by 2. So the value of this expression is 7 by 2, which we are able to find simply by using some trigonometric relations and the values of trigonometric ratios of some standard angles. So that's it for today's video, in which we have seen what are trigonometric ratios, how we can find the sign of these trigonometric ratios in various quadrants, the values of these trigonometric ratios for some standard angles, and how we can find the values of these trigonometric ratios for angles more than 90 degrees. And in the next video, we'll be seeing the graph of some trigonometric functions and some trigonometric identities and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.